All right. Hello, everybody. Welcome back. This is Professor Zayed. I'm recording this lecture about big data analytics. And I have recorded previous lectures about big data in general. And now I'm talking about analyzing big data. And if you didn't watch my previous videos, I'm here mentioning what I'm going to do is I'm going to define big data before we talk about analyzing big data. So basically, big data is the fact that we gather so much data every day. So it's a data set that is so large and complex that are collected daily from different sources. You have data collected from social media sites, from IoT devices, from shopping sites, and so on and so forth. So now we will talk about big data. Why is it important to talk about big data? Why is it important to talk about analyzing big data? All this data that's being collected daily, why is it so easy to collect data today than it was before? Because now there has two things happening here. We have data that we have storage that are a lot cheaper. You can store data as much less lower cost, bigger data and lower cost, and you can also store data on the cloud too. You have sites like cloud providers like Amazon, AWS, and Google. You can store a large amount of data. So now we talked about big data and defined the big data. What is big data analysis? When you analyze big data, you basically extract meaningful information. You get meanings out of raw data using specialized computer systems. These systems, what will do is they will transform, organize, and model the data to draw conclusions and identify patterns, right? So you have data, you can make predictions basically from big data. You can detect fraud and so on and so forth. So big data now there's many sites out there talk about like big data as so much data is being collected daily, stored, analyzed using cloud computing as well. So some sources talk about by 2020, which is last year, minimum 1/3 of all data will be stored and analyzed using cloud computing. So it's very important today to understand what does that mean for companies to store the data on the cloud and be able to analyze the data without even storing the data locally on their devices. So the data analytics process has some components that can help a variety of initiatives. How would it do that? It will do it by combining the components. A successful data analytics initiatives will provide a clear picture where you are, where you have been, and where you should go. So making predictions basically. So again, big data analytics is a process of extracting meaningful insights from big data, such as hidden patterns, unknown correlations, market trends, and customer preferences. There are a few types of data analytics. One of them is called predictive analytics. Another one is prescriptive analytics, diagnostic, and descriptive analytics. We're going to be talking about each one of them in more details. So, so we have data on everything, right? Everything we do is basically increasingly being digitized. So there's a lot of data out there has been stored, and a lot of the data has been gathered and stored on a cloud computing. So let's talk about each one of them separately here. Predictive analytics basically means that is the practice of extracting information from existing data sets in order to determine patterns and predict future outcomes and trends. Predictive analytics does not tell you what will happen in the future. Okay, it makes predictions. So what will happen basically looks into the historical and present data to make the predictions of the future. This type of analytics uses data mining, artificial intelligence, and machine learning to analyze current data to make predictions about the future. So this works on predicting the customer trends, market trends, and so on. So this analysis works on probability. A good example of that is a company like Spotify, for example. It's been talked about, you know, how Spotify does has millions of users. And basically what it does, it collects a huge amount of data. And this data, what will Spotify do with it? So they will analyze that data and basically to be able to send recommendations to their customers on what should they listen to. Okay, so they have filter tools, and so what they do is they predict basically based on historical and what users are listening to today. It will predict basically what will users will listen to tomorrow. So they make recommendations based on that. Big data is increasingly used to optimize business processes. Retailers are able to optimize their stock based on predictions generated from social media data, web search trends, and weather forecasts. So HR business processes are also being improved using big data analytics as well. So understanding some of the things that you can do with big data analytics when it comes to predictive analytics, you can basically, some of the benefits are understanding and targeting the customers. That's what businesses would be able to do with this type of analytics, understanding and optimizing business processes. Also, another benefit is personal quantification and performance optimization, and improving healthcare and public health, improving sports performance, optimizing machine and device performance, improving security and law enforcement, improving and optimizing cities and countries, and financial trading as well. So basically, so the ability to make predictions and provide these benefits. Many businesses today use this type of predictive analytics to gain some of these benefits that we talked about. So market predictions of big data, basically, some studies indicate that by improving integration of big data, healthcare, it could save a lot of money, like probably 300 billions a year. It was some sources. This boils down to reducing costs by 1,000 a year for each person that has access to healthcare. Okay, so what has happened is descriptive. So the second part of the analytics is called descriptive analytics. So predictive is basically predicting what's happening in the future. Descriptive is describing what has happened today. And even like companies like IT also use this as well to, they use monitoring tools, AI and things like that to be able to describe if anything happens, like some kind of data breaches and things like that. So this type of analytics, it summarizes past data into a form that is interpretable by humans. This analytics helps in creating reports like companies' revenue, profit, sales, and so on. This is according to Simply Learn. Tabulation of social media metrics like Facebook, likes, and tweets are done using descriptive analytics. And so we talked about the two things here. We talked about predictive analytics, predicting future events based on historical data and current data as well. But we talked about descriptive, describing what happened, coming up with a solution. So if you're running into a problem, you can basically use this type of analytics to kind of describe and give a reason why you have this issue, like monitoring, for example. But prescriptive analytics is the third one, and is basically meaning that what is a solution? This type of analytics prescribes a solution to a particular problem. Prescriptive analytics works with both descriptive and predictive analytics. So most of the times, prescriptive analytics relies on artificial intelligence and machine learning. So again, remember, prescriptive is the solution. What is a solution? You can prescribe a solution to a problem. This analytics is used to build an algorithm that will automatically adjust the flight fares based on numerous factors, including customer demand, weather, destination, holiday seasons, and oil prices. This is the example of talking about airline tickets, flights. So that can be used to do that. So using prescriptive analytics. Diagnostic analytics is basically meaning that why did it happen, right? We talked about predictive, predicting the future events. We talked about descriptive and prescriptive, and this one is diagnostic analytics. And this, why did it happen? So you're talking about, one analytics, one basically what's what happened in the future, why it happened, or is basically why did it happen is diagnostic. Um, how it happened, and descriptive, that's descriptive, how it happened. Prescriptive is basically providing a solution, and this type of the analytics diagnostic is why did it happen. This analytics is done to understand why a problem has occurred. It looks into a cause of a problem. So looking into an issue and giving you a reason why this issue happened. So diagnosis, that's what we're talking about, diagnostic analytics. This analytics is characterized by techniques such as a drill down, a data mining, and data discovery. Organizations go for diagnostic analytics as it gives an in-depth insight into a particular problem. So now talking about 5 ways data science is changing financial trading. One is big data analytics. Number 2 is stock evaluation. 3 is real-time information and machine learning. And then number 5, some companies start with AI, artificial intelligence. Text analytics, basically using text tools to analyze text messages or text in general. So known as text mining is the process of extracting value from large quantities of unstructured text data, while the text itself is structured to make sense to a human being, like a company report is split into sensible sections. It is unstructured from an analytics perspective because it doesn't fit neatly into a relational database or rows and columns of a spreadsheet. So a good example of that is taking out interviews, for example, and you want to be able to analyze these interviews. In my own example, when I did my PhD dissertation, I had to record interviews for my dissertation and use those texts to analyze. I used some programs, some tools to be able to analyze the text and gain some insights from them. So text analytics is a process of drawing meaning out of written communication. Traditionally, the only structured part of the text was the name of the document, the data it was created, the date it was created, and who created it. And that's basically means that it's a metadata, data about the data. So when you look up at any file, you can look at the properties of that file. You can get some information about that particular file, like the date that was created, if it was modified, and so on. But that's not the actual data. It's the data about the data. But we're talking about analyzing the text itself. You need some tools to do that. So why do we need text analytics? Emails, online reviews, tweets, call center agent notes, survey results, and other types of written feedback all hold insight into your customers. So there is also a wealth of information and recorded interactions that can easily be turned into text. And here I include the source of some of these and some of this information at the bottom here of the slide. So we're going to be talking about some of the examples of a text analytics tools that you can use. The one that I use personally is IBM SPSS Text Analytics tool. You can look that up on their website, IBM's website. You have tools like Expert System, Discover Text, IBM SSS, Lexlytics, Salience, Provalis Research Text, ByText, Google Cloud Natural Language API, Microsoft Azure Text Analytics, and so on. So there's a lot more, but just these some of the examples that we talked about here. For example, Discover Text here, according to the discovertext.com, it provides dozens of multilingual text mining, data science, human annotation, and machine learning features. So according to this site as well, discovertext.com, they offer a range of simple to advanced cloud-based software tools, empowering users to quickly and accurately evaluate large amount of text data. So again, this is Discover Text, offer text survey and Twitter analytics in data science. You can look up their website, discovertext.com. IBM SPSS Text Analytics for surveys automates the process while still allowing you to intervene manually to refine your results, so you never lose control of the categorization process. Again, this is from their website, IBM SPSS. With IBM SPSS analytics for surveys, you can identify major themes without reading responses word for word. And this is exactly what I did when I did my own dissertation and I was trying to analyze the text. I've gone through this process using this particular tool. Now, talking about business intelligence, applications that transforms data into meaningful information, which helps businesses make better decisions. The term business intelligence came into use around 1950s, and it grew out of technology called decision support system. Business intelligence systems have grown more powerful and comprehensive, basically due to increased data collection, due to the rise of smartphones, wearable devices, internet, social media, and so on and so forth. So also we have now greater storage capacity. We have, hard drives and that stores a lot more data than used to be. And also we have the ability to store a large amount of data in the cloud as well. So companies now have access to smartphone metadata, internet usage records, social media activities, and so on. So business intelligence platforms sift through this data to find patterns and trends. According to statistics, MRC, the global business intelligence market is expected to grow from 15.64 billion in 2016 to reach 29.48 billion by 2022, which is next year. So this is we are in 2021. So this predicting within 6 years, basically the market is expected to double. So, and the source for this this statistic is here on this website below here. So now data comes in three main forms. They come in structured data, semi-structured, and unstructured data. And let's talk about each one of them separately. Data resides in a fixed form. It's called the structured data. So basically, this is like name, collection, forms on websites, and so on. So it's easy for computers to read and query such information because the data has already been standardized. That's called the structured data. Structured data resides in a fixed form. Unstructured data is the information that can't be easily read by computers, including text documents, videos, or any information that isn't clearly sorted or can't be organized into databases. So it's difficult to organize in traditional databases because it can't be stored in rows and columns. So this is called unstructured data. So a good rule of thumb is that 80% of all data produced are or is unstructured. So lots of that data out there that gets gathered, collected daily, they are unstructured data. A lot of it doesn't even get analyzed. So much data is being collected today. And there are some statistics that I talked about before about the amount of data that, like for example, I mentioned earlier in a different lecture that the data is growing. Some of the sources talk about data is growing in a rapid pace. So by 2020, for example, some sources talk about new information generated per second for every human being would be around 1.7 megabytes. And also some of the other sources talks about the accumulated volume of big data. It will increase from about 4.4 zettabytes to 44 zettabytes, or 44 trillion gigabytes of data. So that's a lot of data collected every day from like social media sites like Facebook, Google, Twitter, YouTube, and so on. So company data isn't always in one location. You have a company, you find the data will be found in different areas, different platforms in different areas. So you have CRM programs or customer relationship management programs, collect data, marketing automation systems, and social media platforms, and more. So the first step is in BI or business intelligence is taking inventory of the data your company produces. So where are your data stored, right? So you have some data maybe locally on a file server somewhere in your business. Some of that data will be on a cloud platform like AWS and maybe Google accounts and so on and so forth. So the first thing, the most important thing, if you want to analyze the data, you need to have a way of understanding where all your data is and then take inventory of that data. Data warehouse basically is used to consolidate disparate data in one location. Using a process known as extract, transform, and load, ETL, data warehouses standardize data across systems, which allows it to be queried. So it's like basically bringing all that data from one location and then having that data in one place. So like having a data center, for example, for AWS, where they store all the data in one place, but then they have a backup copy of that data somewhere else. So again, talk about extract, transform, and load. So we have the data sources here. We talked about CRM, customer relationship management, flat files, and then you have ERP systems and so on. So the method of standardizing and centralizing data is known as extract, transform, and load, or ETL. So extract is basically raw data is extracted from a source program like a CRM, customer relationship management, or an ERP system or enterprise resource planning. This is often where unstructured data such as notes or author information is tagged with metadata to make it easier to find. So again, as I mentioned, for my PhD dissertation, I conducted interviews and took notes and recorded conversations. And I used actually a couple programs, one in Vivo software, I used IBM as well. So transform is basically, so we talked about extracting the data. Once you extract the data, you transform the data. So during this step, the data is normalized. In order to properly analyze the data, it must be in the same format. Think apples to apples, rows and columns, or some kind of forms that you will be able to query. And the next thing is, after transform the data, is you load the data. Data is transformed into data warehouse or data mart. This process can occur every week. So when you upload the data to a warehouse or somewhere like a data center, you can choose when that data will be uploaded or loaded up to the system. You can do that once a week, every day, every hour, or even every minute. It depends on how much bandwidth you have available. So the more often this is done, the more up-to-date analytics reports will be. So for example, I'll give you a perfect example of this. If you are, in my example here, I'm backing up my data on my computer. Regularly, I plug in an external drive where I have that data automatically gets backed up when the drive is recognized by my system. But if I plug in that computer within 10 minutes, the data will be updated on the external drive. So now it's kind of slows down my system a little bit because it's writing to another drive. But if I'm doing this every 10 minutes, or I can do it every day and so on. So if I lose my data, if I don't back up my data to external drive or upload it, and I lose my drive, my internal drive, the data is lost up to the point where I did my last backup. So keep that in mind. So data marts are essentially smaller, more focused warehouses. So smaller than a warehouse. So when you hear the word data mart, it's like a smaller version of a warehouse. Instead of aggregating data across a company, the data mart might store the information of just a single department, like data of a marketing department only. So when you store the data of one department in one place, that's called data mart. Okay, so data marts limit the complexity of databases and are cheaper to implement than full warehouses. So it depends on the budget of the organization how much you're willing to, to pay for getting all that data in one place. It depends on the budget that you have in place. So if you're looking for a cheaper option, you can choose a data mart. So again, big data analytics has the power to provide insight about people that are far and above what they know about themselves. And the analytics basically is the discovery, interpretation, and communication of meaningful patterns in data. So especially valuable in areas rich with recorded information. Analytics relies on simultaneous application of statistics, computer programming, and operations research to quantify performance. And again, talk about predictive analytics. We talk about the large sets that may be analyzed computationally and reveal patterns, trends, and associations, especially relating to human behavior and interactions. So again, predictive analytics, data mining, and trends. This is from this source here that I have at the bottom of the slide. And this is the end of the slide here. So again, we talked about the 4 types of data analytics. We talked about predictive. We talked about descriptive. We talked about diagnostic. And so we talked about things like what diagnostic basically means, why did it happen? That's what diagnostic means. We talked about prescriptive analytics, which is basically the solution, prescribing a solution to a problem. And we talked about descriptive analytics, which basically describes what happened. It summarizes the past data into a form that is interpretable by humans. And we talked about also predictive analytics, which is used to predict future events based on things that happen in the past, historical data, or things that are happening currently. So thank you so much for listening, and I'll see you in the next video.